Hello everybody. Today I have a video on vectors. Now what is a vector? It's a very simple thing in actuality. All it really is a magnitude and a direction. So what do I mean by magnitude? By magnitude I simply mean a quantity that is a measurement of the distance of the vector. So let's just say in this case that this vector is 20 meters long. As for the direction, let's just say that you could put a Cartesian plane around it, and right here would be the origin, and you could say that there's an angle right there. So it would be the angle above the origin would be the direction. Let's say the angle is 45 degrees. Now, a common thing that you would have to figure out, especially in introductory vector questions, problems, is how far in the x direction and how far in the y direction your vector goes. So then, what does this look like? It looks like a right triangle. So, if you know there's a right triangle, you could use trigonometric properties to figure out how far in the x direction, how far in the y direction it goes. So, let's think about the most basic of trigonometric properties. So, ka, toa. Remember SOHCAHTOA? So SOHCAHTOA, so we get sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And then the other thing you have to remember is the Pythagorean theorem. Pythagorean theorem, which is simply a squared plus b squared is equal to c squared, where all you really have to remember is that this long line is c. So let's find the x direction then of this. So let's see, the x is right here, correct? And that is adjacent to the angle. So we use cosine. So we have cosine of theta of the angle is going to be equal to adjacent, which is what we're looking for, over the hypotenuse, which is, so cosine of 45 is equal to a over 20. So we have 20 cosine of 45 is equal to, let's just say, x now. As for y, it's basically the same thing, but now we're using sine of theta because this is opposite. So we use sine of theta. So we have opposite over hypotenuse. Then we have, now let's just skip ahead and just say sine of 45 is equal to y. Now, all you have to do is really plug numbers in at this instance. So 20 sine of 45 is equal to 14.14. Now, sine of 45 and cosine of 45 are the same exact thing. So x is going to be 14.14 as well. So that is the most basic of things to remember in terms of vectors. Another thing is that you'd often have problems where you have many directions happening, many vectors occurring, at which point you say, okay, this is the first vector going here, and then the second vector say goes in this direction, and you just keep layering them on top of each other as so. At which point you usually be asked for something called the displacement, and in this case the displacement would be right there. And the angle would be, well, in this case there would be no angle, but if it's another one as like this, the displacement from the origin would be here, and the angle would be there. And I'll go over a problem just like that in the next video. Thank you.